All right, guys. So this is just an extra little video I'm gonna have you guys watch at the beginning of class. Uh, One of the things that is important to this chapter and this concept is the fact that we have the pieces we need for the plan. So let's just a quick reminder that when we get a sampling distribution of the sample statistic, we get this idea that the middle mu of p hat is equal to p. Okay, that's our thing. We're using this here to estimate the value of p, and to do that, we have to have some conditions. Okay, and that's where the plan comes in. And these conditions, we'll call them conditions. They have to be met. Those conditions have to be met before we can actually say this. Okay, so once we have these conditions met, then we can actually say this. That's the key piece. So that's what the plan's for. So there's certain things that we have to do in the plan. Number one, you have to test for normality, and remember that's n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So that has to be, you have to check box those. So that's got to be done, and that's got to be done. You got to show it, you have to do the calculations, and you have to put it there. You also have to show that the population is 10 times bigger than the sample. And with this, you can make assumptions. Okay? So we can make assumptions. So if we do that and we make assumptions, or we show that the population is 10 times bigger, then we can say two things. We can say conditions are met, therefore mu of p hat is equal to p, and sigma of p hat is equal to the square root of p times 1 minus p over n. That's what the plan's for, okay, guys? So, what's up, buddy? All right, thank you. That was Mr. Welch, guys. He just wants to interrupt the video. So when the conditions are met like this, then we can go to the do part. And the do part, remember, is usually finding the area under a curve right now. Okay? So that's the p hat part. The x bar part, which is what we've got for Friday, the x bar part, and let me erase this here and move it over just a little bit. So let's go back to, let's do x bar to estimate mu. Okay, so when we look at this, it's the same idea, except instead of mu of x bar, we have our sampling distribution of the sample, our mu of x bar. We want to make it equal to mu. And how do we do that? We have a plan. And right now, our conditions are a little different. We call this the central limit theorem. What's the central limit theorem? If n is greater than or equal to 30, you can assume it's normal. Now, if that happens, if these conditions are met here, if that condition is met, then that gives us the opportunity to state two things. So if the conditions are met, the conditions are met, mu of x bar equals mu, and sigma of x bar is equal to the standard deviation divided by the square root of n. And then we move down to the do part, and we end up with, again, the area under the curve right now. Okay, so I just wanted to bring to light that that's the big new piece for us, is the plan and the conditions. So now we're starting to use some multiple different things. And don't forget, a lot of these formulas right here in the plan part, wherever where the heck did it go? These guys right here, all this stuff, those are all on the formula sheet. This is N, by the way. Okay, so finish up this video, and then we're going to do some example problems in class. But I wanted to give you guys a little bit of difference of of the difference between the two. All right, see you soon.